Problem number 15, we've got this curve. We need to find, the first job here is to figure out dy dx. Again, let me just point out, we have an a and a b. Those are unknown constants. Okay, implicit differentiation. We need to take the derivative of both sides here with respect to x. The derivative with respect to x at a x squared y, we need to use the product rule here. So it's going to be a times the derivative x squared times y. So that would be a times 2x times y plus a times x squared times the derivative y with respect to x. So you might think that the derivative here is 1, but it's 1 times dy dx. Similarly, let's see here, minus, okay, so the derivative of the x times y squared. So that would just be minus 3y squared minus 3x times the derivative of y squared with respect to x times 2y dy dx. The derivative with respect to x of 4, x is just 4. The derivative of b is a constant, is 0. Okay, so this is our first line in implicit differentiation. Taking the derivative with respect to x here. Now we need to solve for dy dx. So we're going to keep all of the dy dx terms on the left here. Dy dx times ax squared minus 3x times 2y. I guess I should write that as 6xy. And then all of the non-dy dx terms need to go to the right. So negative 3y squared becomes positive 3y squared. 2axy becomes negative 2axy. And oops, there's one more over here. Positive 4 becomes negative 4. And so then we divide both sides by the ax squared minus 6xy to come up with dy dx is equal to 3y squared minus 2axy minus 4 over ax squared minus 6xy. And if you check for yourself, that is the desired answer in part A. Okay, part B says, suppose the tangent line to the curve at the point positive 1, 1 is y is equal to 1 plus 5 times x minus 1. This is tangent line at 1, 1. What information is this giving us here? This is giving us what A is. How is that giving us what A is? It's showing us here, we should be able to read off of this. This is dy dx at 1, 1. So when x is 1, y is 1, dy dx is 5. The slope of the tangent line here is 5. That's dy dx. So now we can plop in dy dx is 5. Everywhere I see x and y, x is 1, y is 1. 5 is equal to 3 times 1 squared minus 2a times 1 minus 4 all over a times 1 squared minus 6 times 1 times 1. So 5 is equal to 3 minus 4, that's negative 1, minus 2a, all of that over a minus 6. Okay, great. What do we have here? We need to solve this equation for a. We can do that by multiplying both sides by a minus 6. And so we have 5 times a minus 6 is equal to negative 1 minus 2a. 5a minus 30 is equal to negative 1 minus 2a. Adding 2a to both sides, 7a. And adding 30 to both sides, 7a is equal to 29. So I haven't botched up my calculations here. A is equal to 29 over 7. And then the very last thing that we have to do is, in part C, use our answer to part B to find the value of B itself. we're going to do that by saying at the point 1, 1, we know, yeah, when x is 1, y is 1, we can plop all of this stuff in here. So let me just recopy down. Ax squared y minus 3x y squared plus 4x is equal to b. A is 29 over 7, and we know the 0.11 is on the curve. So 1 squared times 1 minus 3 times 1 squared plus 4 times 1 is equal to b. So this is 29 over 7 minus 3 plus 4 is equal to b. This would be 36 over 7 is b.